Okay guys, we're going to go ahead and do 10.2. Go ahead and try the warm-up, put me on pause, and then hit resume. Go ahead, hit pause. An example of an algebraic expression is, well, first thing, let's notice, it says expression, which eliminates this one, because that's an equation, it has an equal sign. This one, that's an equation, it has an equal sign. And this one, because that's an inequality. So the only one that's an expression is that one. Algebraic means that it has numbers and or variables involved. 10.2, it looks like we're going to do 10.2 in two sections, so you only have to do the video on the 10.2a, and then the next day you'll do the 10.2 part B. Simplifying radicals. Radical, how do you know when a radical is in simplest form? These three show radicals in simplest form, and these three show where they're not in simplest form. Okay, so let's see. How would we know if it's in simplest form? First of all, the radicand has been fully simplified. Square root of 5, square root of x, square root of 2. Those are in simplest form. Square root of 12 is not in simplest form because it has a factor of 4. 4 times 3 is 12, and the square root of 4 can be broken down again. This one is tricky. We'll talk a lot more about this one down the road, but the square root is in both the numerator and denominator, and you cannot have a square root in the denominator. So that's another thing. No radical in denominator. And that's the problem with this one as well. Okay? The third one that you have to worry about, which I don't see involved in any of these, is the coefficient, fractional, let me rewrite that, fractional coefficients. Have to be simplified. For example, like 2 square root of 5 over 10. The square root of 2, or excuse me, the coefficient 2 and the coefficient of 10 can be simplified to 1/5 because you can simplify a coefficient with a coefficient. Okay, so these three are super important. Make sure you get those down. Which I think we're going to talk about here. In here, simplifying radicals. First ask yourself, is it a perfect square? If it's a perfect square, whoops, there we go. If it is a perfect square, like the square root of 25, then you're done. It's 5. Or the square root of x to the 4th. Anything that has an even exponent is a perfect square. That would be x squared. So if it's a perfect square, then the job's done. It's quick and it's easy. If it's not, we have to rewrite it as any non-perfect square as the product of at least one perfect square. So for example, let's use that 12 that I was talking about before. The factors of 12 are 2 times 6 and 3 times 4. I can rewrite 12 as 2 times 6 or 3 times 4, but 2 and 6, neither one of those are perfect squares. Whereas the factors 3 times 4, 4 is a perfect square, and 3 times 4 is 12. So if I rewrite this as two numbers that multiply to this one, and one of them, at least one of them, is a perfect square, then I can say the square root of 4 is 2, and what's stuck under there? The 3. So if it's a non-perfect square, you have to simplify it, which ends up being this, and your answer will have a radical in it, and there's nothing you can do about that. Variables with even exponents, like the square root of x to the 10th, is half of it, so it's x to the 5th. So anytime you have an even exponent, it's a perfect square. If it's an odd exponent, for example, x to the 7th, that's odd. That's not a perfect square. So therefore you have to break it down, simplify it. The most number of even x's I can get out of that would be 6 of them. So if I rewrote that as 6 of them, plus I need one more to have a total of 7, I pulled out an even number, and the square root of x to the 6 would be x to the 3rd, and what's left? Square root of x. Whoops, so we're going to do more of those. Okay, So that's the basics, but we're going to actually look at these in detail. All right, we're going to simplify this two different ways. Square root of 32. I'm going to do it one way, then I'm going to do it another way over here. The first way I'm going to do it is I'm going to say, what numbers, 32 we know is not a perfect square, so we're going to have to simplify it. And I didn't talk about this, but the index of this is an imaginary 2, which they'll never write there for you. That just means it's a square root. So if you don't see anything there, you know it's a 2. Think about the numbers that multiply to 32. 1 times 32, these will never help you. 2 times 16, 3, 4 times 8. When I usually ask kids, if I say, give me two numbers that multiply to 32, most of the time kids will tell me the 4 and the 8. Not always, but most of the time. So let me show you what happens. 4 times 8 is a good pick because the 4 is a perfect square. So anytime whatever numbers you pick here, make sure at least one of them is a perfect square. The square root of 4 comes out as a 2. Whatever numbers come out as a perfect square, you multiply by the leading coefficient. In this case, it's an imaginary 1. So we get 2 times 1 is 2, and 8 is still in there. Now you have to ask yourself, is 8 fully simplified? In other words, can I break it down again? 1 times 8 doesn't help, but what about 2 times 4? 2 times 4 gives me 8, and 4 is a perfect square. So I have to simplify it again. Square root of 4 is 2. Take the 2, multiply it by the leader. 2 times 2 is 4. What's left? 2. Now is this fully simplified? There is no other multiples or factors of 2 other than 1 in itself that will actually be able to simplify down more. So that's my final answer. The other way of doing it is for those kids who realize, 4 times 8 will work. However, I know 2 and 16 gives me 32, and 16 is a perfect square as well, and it's bigger than this guy. So if I use the bigger perfect square, if I even have that choice, not always will you, but if I have that choice and I use the bigger one, then the square root of 16 is 4, 4 times my leading coefficient, and I'm done in half the work. So what do you learn from this? If you pick the larger perfect square, if you're given that choice, you will save yourself half the work. If you pick the smaller one, then you will have to double up on the work, but you still can get the job done. All right, let's look at these examples. It says 3 root 6 times 1 root 18. That's not supposed to be there. We have a coefficient, multiply coefficient times coefficient, radical times radical, radicand times radicand. You can simplify first, or we can just multiply. I'm going to go ahead and just multiply. So if I do 3 times 1, I would give me 3. And then I do square root of 6 times the square root of 18, so it's just 6 times 18 is the square root of 108. Then ask yourself, is 108 a perfect square? Well, it's not. But can I break it down? Think about numbers that multiply to this multiplied to 108. That's a perfect square. If I list them, 1 times 1 is 1. That won't help me. 2 times 2 is 4. 3 times 3 is 9. 4 times 4. 5 times 5. 6 times 6. If I think about perfect squares, I try to find which one of these, preferably the largest, will go into 108 evenly. I believe 36 works. If you take 108 and divide it by 36, you'll get 3. And the square root of 36 is 6. Remember, whatever comes out, multiply by your leading coefficient. So 6 times 3 is 18, square root of 3. And that's that one. All right, the next one, the leading coefficients are a 1 and a 1, and 1 times 1 is 1. So we don't need to write that, but let's multiply our radicals. 2a times 9a cubed, 2 times 9 is 18. A to the first times a to the third. Remember, when you multiply, you add the exponents. So it's a to the fourth. Excuse me. 18 is not a perfect square, but it can be broken down. Now which perfect square goes into 18 evenly? The 9. 2 times 9. Is a to the 4th a perfect square? It is, because it's got an even exponent. So leave it in there. You don't have to break it down. Let's take out the perfect squares. The square root of 2 is not a perfect square, it's stuck. Square root of 9 is 3, and the square root of a to the 4th is half of that, so it's a squared. So my final answer, multiplying by the leading coefficient, is 3a squared, square root of 2. All right, the next one, coefficient times coefficient. 7 times 3 is 21. Multiply your radicands. 5x times 20x to the 5th. 5 times 20 is 100. And x to the 1st times x to the 5th is x to the 6th. I like this one because 100 is a perfect square and x to the 6 is a perfect square. So because both of them are perfect squares, your answer will be left with no radicals. Multiplying this out, we get 210. X to the 3rd, no radicals in my answer because everything was perfect squares. All right, go ahead and try these on your own. Put me on pause, and then when you finished it, hit resume and see how you did with it. Go ahead, hit pause. All right, simplify each radical expression. Square root of 98. It's not a perfect square. If you think about the perfect squares that we listed before in the last screen, 49 times 2 gives me 98, and 49 is a perfect square. It's 7. 7 times 1 is 7. Square root of 2, fully simplified. Okay, make sure it's fully. In this one, 16 is a perfect square, so I'm going to leave it alone for now. B to the 5th is not. That's an odd exponent, so I need to break it down. What's the most number of even b's I can get? That would be 4, plus I'm 1 short, so I got to add another one in there. So I have a total of 5 now. So let's take out the perfect squares. Square root of 16 is 4. Square root of b to the 4th is b squared, and b is stuck. So I'm left with 4b squared times 1 is 4b squared, square root of b, and I'm done. Okay, hopefully you did well on that. If not, make sure you come and see me.